Hello everyone. Today's video is on general water usage. The learning outcomes of today's video are to define water resource management and to define consumptive water usage. We are working with a finite hydrosphere of water here on the globe. And so water usage, when people talk about running out of water, is actually not running out of water because we are going to keep continuing to have the same amount of water that we had before, but it's really about getting water to where it is needed and where it is being used. So here you can see sort of the amount of precipitation that happens in the eastern United States is a lot higher than what happens in the western United States. And some of these regions in the western United States are supporting populations that compete with the southern United States, but there's not water in those regions to support those populations and those industries. So that's where water usage and water resource management comes into play. Here are the daily US water flows. Each one of these numbers represents 1 billion gallons of water per day. You can see reservoirs in the western United States. About 15 billion gallons of water from those reservoirs just evaporates into the air. And then we have flows, stream flows in the Pacific Northwest in the western United States to the Pacific Ocean. Precipitation represents about 4,200 billion gallons of water per day, which is really, really large. And that sort of matches the amount of evaporation experienced from wet surfaces in the United States. So it's sort of that hydrosphere, the hydrologic cycle at play here. Consumptive water usage are much smaller than that, at about 106 billion gallons of water per day, but it's still quite comparable. It's probably 10% of those water withdrawals. So that's something to think about when we think we move further down into this unit. That consumptive water usage is rather significant on a US scale, which is very interesting. Water resource management deals with the allocation of water, where it is at to various consumers in those areas. And so that can deal with water resource management, damming, channelization. All of these flood control measures that we've talked about is a type of water resource management, and different pipes, channels, aquifers, things like that. When to pull from surface water as to whether to decide when to pull from groundwater is something that a water resource engineer has to make on a regular basis. So let's talk more about consumptive water usage, because that's really what it comes down to is human beings' usage of water. Our consumptive water usage is often exceeding the amount of water that is available in that area, or available in that area for sort of extraneous purposes such as irrigation or thermoelectric power generation. So consumptive water usage means that this is water that is removed from the immediate environment and changed in some way. So it's either gone through a phase change, so water that is evaporated, it's going from a liquid to a gas, transpired, that's going from a liquid to a gas through plants. That water is being consumed by that process. So water sitting in a reservoir is evaporating a lot. That's a form of consumptive water usage because that water is no longer available in its previous state. So we've intervened and caused that water to change and be removed from its immediate environment. This water can be consumed by humans or livestock. So drinking water, irrigation, and incorporating water into crops is also a big form of consumptive water use. So irrigation actually withdraws a lot more water than the water that it consumes. So to think about this, you apply water, you irrigate your field with water. Some of that water is evaporated off, some of that water is taken up by that plant and incorporated into your corn or your crop product. And then a good majority of that water, if it's in a good climate, is actually returned to the watershed. So in that instance, the water withdrawn exceeded the amount of water that was consumed because some of it was returned as liquid water to the existing source. I read a great book called Where the Water Goes, and it talked about water usage along the Colorado River. But it basically talks about how irrigation actually acts as sort of a natural reservoir, and slows the amount of releases of water back to the ocean. Um, and the issue in the West is that the amount of evaporation that occurs far exceeds the amount that is returning to the river. And so irrigation and agriculture that's happening in places that have a lot more water, that experience less evaporation, they probably use similar amounts of water, but that water as a whole is not being consumed in that instance. So the irrigation and agriculture happening in the Western United States is more consumptive than if it was on the Eastern United States. So water withdrawals is just taking water from a river and consuming it. Consuming it is meaning that it's not returning to that river in some way. And so I want to point out that this thermoelectric power generation uses a ton of water, and that's because it's intaking water from a river. It's using that water to turn a turbine or absorb heat, and it's used in some sort of heat exchanging capacity, but it's eventually returned to the river. And so power generation typically only consumes 10% of the water that it's withdrawing because most of that water is being returned to the source. So it's consuming some of that water, it's being evaporated, it may be contaminated, but it as a whole is just borrowing the water and then returning it to the river to be used for something else, for nature, another water purpose. Paper mills, places where paper pulp is made, they use a ton of water in a similar fashion, but it's all consumptive because that water gets contaminated with lye. You have to basically turn the wood into a pulp and spend it in a watery lye solution. And so that uses a lot of water, but it's all consumptive in that instance because we're not able to take that bleached water and just put it back into the river. So that's the difference between a consumptive and non-consumptive water usage. Power generation is just borrowing it for a little bit. They're adding maybe some heat to it and then returning it to the river. Whereas an industry that is utilizing it in some way to wash something in a chemical or evaporated in some fashion, that is a consumptive water use as opposed to just a water withdrawal. And so that concludes our video for general water usage. You'll note in our following videos that a majority of water is used by agricultural purposes in the United States. So if we want to make big changes in the way we use water, agriculture is a great way to make a lot of headway in that regard. But feel free to reach out to me if you have any questions, and I will see you next time.